All right, let's talk about the internet. We use it every single day, but how does it actually work? We're going to pull back the curtain and demystify this thing that's, let's be honest, pretty incredible, but also totally misunderstood.
Okay, think about this for a second. You snap a photo, you hit send, and bam, it's on your friend's phone, maybe thousands of miles away, almost instantly. How? I mean, seriously, what's the journey? Does it get zapped up to a satellite? Does it just kind of float around in the cloud? Well, the truth is, it's a whole lot more physical, and honestly, way cooler than magic. It's not really about satellites. Get this. Over 95% of all international internet traffic travels through a massive, hidden network of undersea cables. We're talking about lasers and fiber optics at the bottom of the ocean. So, to really get how this all works, we've got to start at the very beginning. Let's trace that photo from the second it leaves your phone. This is what you could call the internet's first mile.
Believe it or not, your phone is basically a really, really smart radio. I mean, at its core, that's what it is. Whether you're connected to Wi-Fi or using cellular data, it's turning your picture into radio waves and beaming them to the closest receiver. You know, the router in your living room or the cell tower down the street.
Okay, but here's a key thing. It doesn't send the entire photo in one big chunk. That would be super inefficient. Instead, your phone is like a digital paper shutter. It chops up that photo into thousands of tiny little pieces called packets. You can think of each packet like a tiny envelope, all part of the same letter, getting ready for a big trip.
Now, before these little envelopes can go anywhere, they need an address label, right? Each one gets a port number. That's just to make sure it lands in your friend's photo app and not, say, their email inbox. Then it gets the main shipping address, the destination IP address for your friend's phone. Once all that's done, they're converted into signals and they are officially ready to go.
So those radio waves hit your router. And your router, it's like a translator. It takes those packets and instantly converts them from radio signals into incredibly fast pulses of light, literal laser light. And then, zap, those light pulses are fired into a fiber optic cable. And that's the start of the wired part of the journey. All right, so our packets are on their way. They've officially left the building. Now, let's zoom way out and look at the global superhighway they're about to hit. 400. That's the key number here. The backbone of the internet, the thing that holds it all together, it's not floating in the clouds. It is a physical web of more than 400 massive, garden hose-thick cables lying on the bottom of the ocean, physically connecting all the continents. Yeah, and this quote from Vox really hits it home. It reminds us that there's an immense amount of physical labor behind our digital world. I mean, these cables don't just magically appear down there. They are painstakingly laid by special ships in a process that takes months of incredibly hard work, sometimes even plowing them into the seabed for protection. And when you look closer, the details are just wild. Inside these super thick armored cables, you've got these glass fibers that are as thin as a single human hair. And that's what's carrying our data as pulses of light. And, you might have seen that video of a shark biting a cable, but turns out sharks aren't the big threat. It's us. The biggest danger is actually fishing trawlers and ship anchors dragging along the ocean floor. Okay, so just imagine this. Trillions upon trillions of these tiny packets are zipping around the planet through this physical web. The obvious question is, how on earth do they know where to go? With all that traffic, how do they not just get completely lost in a massive digital traffic jam?
Well, the answer is this little box, the router. Routers are pretty much the unsung heroes of the entire internet. Think of them as the traffic cops of the digital world. They're basically super specialized computers whose only job is to direct all this packet traffic, telling each one where to go next. And what a router does is actually pretty simple, just insanely fast. It grabs a packet, glances at the destination IP address, checks its internal map, which is called a routing table, and just forwards it to the next closest router on the best path. And it does this millions of times every single second, all over the globe. The whole system works because that shipping address we talked about, the IP address, is just a string of numbers. It's a language that computers understand perfectly. It's precise, it's logical, there's no confusion. But who can remember a string of numbers like that, right? When you want to go to Google, you type google.com, not 142.250.190.78. So there's a missing step here. How does google.com get translated into a number that the routers can actually use? This is where the final piece of the puzzle clicks into place. It's called the Domain Name System, or DNS. The best way to think about it is as the internet's giant phone book. It's that simple.
When you type in a web address, your computer's first stop is to ask a DNS server, hey, what's the phone number for google.com? The DNS server looks it up, gives back the IP address, and only then can your computer send your packets to the right place. So, let's recap. Our little packets have been chopped up, shot across oceans as light, directed by superfast traffic cops, all thanks to the internet's phone book. Now, let's finish the journey and see what happens when they finally arrive. Okay, so the packets start flooding into your friend's phone. And here's the thing. They might not even arrive in the right order. Some might take a slightly different path. But the phone's software acts like a puzzle master. It gathers all the packets, checks to make sure every single one is there, and then reassembles them in the perfect order. And voila, your photo appears on their screen exactly as you sent it. So you can see the whole journey in a nutshell right here. What feels like one single magical action, sending a photo, is actually this incredibly complex, multi-stage physical trip. You send it, it gets broken into packets. It becomes radio waves, then light and undersea cables. Then it's directed by these traffic cops called routers. And finally, it's all put back together. It's a wild ride. So if there's one thing to remember from all of this, it's this. The internet is not a cloud. That's just a marketing term. The internet is a real, physical, human-built marvel. It's a tangible thing that we are constantly building and fixing, and it's what connects our entire planet. And just look at how fast this thing has grown. I mean, in a little more than a decade, the number of people on Earth with internet access has almost doubled. This physical web that we've been talking about has completely reshaped our world in the blink of an eye. And that kind of leaves us with one final big question. We've seen the incredible engineering, this amazing human achievement that connects all of us. But as we keep laying more cables and connecting billions more people, you have to ask, who is still being left behind? Why isn't this amazing connection available to everyone yet?